Hello there, and welcome to the Deep Sleep Seas channel. I'm so glad you found your way here tonight. Perhaps you've had a long day, or maybe you're simply the kind of person who finds comfort in drifting off to the gentle rhythm of ocean mysteries rather than counting sheep. Either way, tonight's journey is for you. You have nothing to do but rest. Let your mind settle, your breathing slow, and your body grow light, as if the waves themselves are gently rocking you towards sleep. Tonight we're swimming alongside one of the ocean's most enchanting creatures, not in hurried pursuit, but in calm observation. We're going to drift through the world of dolphins, those graceful inhabitants of the sea who seem to carry joy in every movement, intelligence in every glance, and mystery in every sound they make. Some of what you hear tonight may surprise you. Other facts may simply wash over you like gentle waves, carrying you deeper into rest. And that's perfectly fine. There's no test tomorrow. No need to remember everything. Just let the words flow. Let the images form softly in your mind's eye and allow yourself to sink into the peaceful world beneath the waves. Before we begin, if these calm explorations help you unwind, if they give you a quiet way to end your day, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time, one peaceful night at a time. Now let's slip beneath the surface and begin our gentle journey into the world of dolphins. Dolphins carry within their heads one of nature's most sophisticated creations. A brain so complex, so layered with folds and connections, that scientists have spent decades trying to understand its depths, and what they've discovered is nothing short of extraordinary. The brain of a bottlenose dolphin weighs about 1,600 grams, roughly the same as a human brain, sometimes even slightly larger. But here's where it gets interesting. When we compare brain size to body size, dolphins are second only to humans in something called the encephalization quotient. This is simply a measure of how large a brain is compared to what we'd expect for an animal of that size. Humans have an encephalization quotient of about 7.0. Bottlenose dolphins, they're right there with a ratio between 4.1 and 5.0, higher than any great ape, higher than elephants in some measurements. Their brains are about 4 or 5 times larger than what we'd expect for their body size. But size isn't everything. It's what's inside that truly matters. The dolphin brain is structured in ways that mirror our own, yet with fascinating differences that make them uniquely suited to their aquatic world. Their neocortex, the part of the brain responsible for complex thinking, perception, and reasoning, is incredibly convoluted. In fact, it's more folded and layered than the human neocortex. These folds aren't just for show. They increase the surface area of the brain, allowing for more neurons, more connections, more processing power packed into that streamlined hydrodynamic head. Deep within these folds, scientists have discovered something remarkable: spindle neurons. These are special brain cells, elongated and distinct, found in only a handful of species on Earth. Humans have them. Great apes have them. Elephants have them. And dolphins have them. And dolphins have them in abundance. These spindle neurons are associated with some of our most sophisticated mental abilities: recognition, memory, reasoning, communication, the ability to understand and respond to social situations, the capacity to perceive and adapt to change, and perhaps most intriguingly, they're linked to our ability to process emotions, to understand what others might be feeling, to experience empathy. What makes this even more fascinating is where these neurons are found in the dolphin brain. They're concentrated in areas associated with emotional processing. The limbic system, that ancient part of the mammalian brain responsible for feelings, for drives, for the emotional coloring of our experiences, is remarkably well developed in dolphins. In fact, some neuroscientists suggest that the dolphin's limbic system may be even more complex than our own. Their capacity for emotional depth, for feeling connected to others, for processing the rich social world around them, may rival or even exceed what we experience as humans. This neurological architecture supports what we observe in dolphin behavior. They demonstrate self-awareness, passing the mirror test, a benchmark of consciousness where an animal recognizes its own reflection rather than treating it as another individual. When researchers marked dolphins with temporary markings and gave them access to mirrors, the dolphins examined those marks on their own bodies, sometimes spending considerable time inspecting themselves. This level of self-recognition suggests a sophisticated sense of self, an understanding that this body is me. Their problem-solving abilities are equally impressive. In studies, dolphins have demonstrated the capacity to understand complex concepts, to categorize objects, to grasp abstract ideas that many other animals struggle with. They can learn sequences, understand symbolic representations, and even comprehend basic aspects of human-created languages. In one famous series of studies, dolphins were taught to respond to hand signals and visual symbols, creating a kind of interspecies communication. They could understand sentences with multiple elements, distinguishing between bring the ball to the hoop and bring the hoop to the ball, showing they grasped not just individual words but the relationships between them, the syntax that gives language its power. Their memory is extraordinary. Studies have shown that bottlenose dolphins can remember the signature whistles of other dolphins they've lived with for more than 20 years, even after decades of separation. Imagine recognizing the voice of a childhood friend after 2 decades apart. That's the kind of memory we're talking about. Each dolphin has a unique whistle, like a name, and they carry the memories of these calls across their entire lifespan. This isn't just rote memorization, it's recognition, the ability to hear a sound and instantly connect it to an individual, to memories of interactions, to relationships forged long ago. This cognitive sophistication emerged over millions of years. The ancestors of modern dolphins began evolving larger brains around 33 million years ago, in the Eocene epoch. Another significant leap in brain size occurred about 27 million years ago, in the early delphinids, the direct ancestors of the dolphins we see today. These increases weren't random, they were driven by the demands of their environment. The open ocean is a world of shifting alliances, changing conditions and complex social networks. Unlike terrestrial environments where technical knowledge about tools and physical manipulation provides advantages, the ocean rewards social intelligence, the ability to cooperate, to communicate, to understand and predict the behavior of others. Dolphins evolved in an environment where forming alliances meant survival, where remembering who helped you and who didn't could mean the difference between finding food and going hungry, between protection and vulnerability. In such a world, bigger brains, more sophisticated neural circuitry, and enhanced emotional processing weren't luxuries, they were necessities. And so over millions of years, through countless generations, the dolphin brain grew and refined itself into the marvel it is today. All of this complexity, all of these capabilities, exist within a creature that spends its entire life in water, navigating a three-dimensional world where sound travels faster than it does in air, where visibility can be limited, where the challenges are entirely different from those faced by land-dwelling mammals. Yet despite these differences, or perhaps because of them, dolphins developed cognitive abilities that parallel our own in fascinating ways. They became, as one researcher termed them, our cognitive cousins, separated by millions of years of evolution yet converging on similar mental capacities through entirely different evolutionary paths. As you rest tonight, as your own mind begins to quiet and drift, imagine carrying such a brain through the ocean depths. Imagine processing the world through sound, through the complex acoustic environment of the sea. Imagine forming relationships that span decades, remembering voices from years past, understanding the intricate social dynamics of your pod. It's a different kind of intelligence than ours, adapted to a different world, yet remarkably similar in its depth, its sophistication, its capacity for thought and feeling. The dolphin's brain, folded and complex, processing and remembering, feeling and understanding, continues its work even as the animal rests. Which brings us to one of the most fascinating aspects of dolphin life, something so unusual, so perfectly adapted to their aquatic existence, that it seems almost impossible until you understand how it works. Sleep, for most animals, is a state of complete unconsciousness. The brain shuts down, the body rests, and awareness fades entirely. We close our eyes, both hemispheres of our brain synchronize into slow-wave sleep, and we dream or drift in darkness until morning comes. It's a vulnerable state, a time when we're disconnected from the world around us, unable to respond to threats or changes in our environment. But dolphins can't afford such complete unconsciousness. They're voluntary breathers, meaning every breath is a conscious act. Unlike humans, whose breathing continues automatically even in the deepest sleep, dolphins must actively decide to surface and breathe. If both hemispheres of their brain shut down completely, they would simply sink beneath the waves and drown. And so, over millions of years, dolphins evolved one of the most remarkable sleep adaptations in the animal kingdom. They learn to sleep with half their brain at a time. This phenomenon is called uni-hemispheric slow-wave sleep. It's exactly what it sounds like. One hemisphere of the brain enters deep restorative slow-wave sleep, while the other hemisphere remains awake, alert, and functional. The hemisphere that's awake monitors the environment, controls breathing, and keeps the dolphin safe. The hemisphere that's asleep gets the rest and restoration it needs, and then after a period of time they switch. The sleeping hemisphere wakes up, the awake hemisphere goes to sleep, and the process continues. When scientists first suspected this might be happening, they were skeptical. It seemed too strange, too unlikely. But then they began recording the brain activity of dolphins using electroencephalography, placing electrodes on the skull to measure electrical patterns. What they found was unmistakable. While one side of the brain showed the characteristic slow, large amplitude waves of deep sleep, the other side showed the fast, irregular patterns of wakefulness. It was as if two different brains existed in one skull, operating on different schedules, taking turns resting. The visual evidence is equally compelling. When a dolphin is in unihemispheric sleep, one eye closes while the other remains open. The closed eye corresponds to the sleeping hemisphere, the open eye to the awake one. This makes perfect sense when you understand that the optic nerves in dolphins cross completely at the optic chiasm, meaning the left eye connects primarily to the right brain hemisphere, and vice versa. So when the right hemisphere sleeps, the left eye closes. When the left hemisphere sleeps, the right eye closes. It's a perfect system, elegant in its simplicity, profound in its implications. Each hemisphere gets about 4 hours of slow-wave sleep within a 24-hour period. That's 8 hours total of deep sleep, but spread across both sides of the brain, never both at once. During this time, dolphins often swim slowly near the surface, or they may hang motionless, occasionally rising to breathe. In captive settings, dolphins have been observed resting at the bottom of pools, periodically surfacing for air. But even in these seemingly restful moments, half the brain remains vigilant, aware, ready to respond if needed. The reasons for this adaptation are threefold, each one critical to dolphin survival. First, and most obviously, it prevents drowning. Breathing must remain under conscious control, and keeping half the brain awake ensures that the dolphin continues to surface regularly. Second, it provides predator protection. The ocean, especially in certain regions, can be a dangerous place. Sharks patrol these waters. Even in relatively safe areas, staying partially alert allows dolphins to detect threats and respond quickly. And third, it helps with thermoregulation. Dolphins are warm-blooded mammals living in water that can be significantly colder than their body temperature. Maintaining muscle movement, even subtle adjustments in position and swimming, helps generate and retain body heat. Complete unconsciousness would mean complete stillness, and complete stillness in cold water could lead to dangerous heat loss. The neurological mechanisms behind this split-brain sleep are still being studied, but researchers have uncovered fascinating details. In the sleeping hemisphere, certain neurotransmitters drop to minimal levels. In the awake hemisphere, they remain elevated. Acetylcholine, a neurotransmitter strongly associated with wakefulness and attention, shows this lateralization. The awake hemisphere has high acetylcholine levels. The sleeping hemisphere has low levels. Interestingly, other neurotransmitters like serotonin, norepinephrine, and histamine don't show this same left-right difference, suggesting that acetylcholine plays a special role in maintaining the asymmetry of unihemispheric sleep. The corpus callosum, that thick bundle of nerve fibers that connects the left and right brain hemispheres in mammals, is notably smaller in dolphins compared to other mammals of similar brain size. This reduced connection may help maintain the independence of each hemisphere, preventing the sleep state in one side from spreading to the other. Each half of the brain maintains a degree of autonomy, operating semi-independently while still coordinating when both need to be fully awake. Dolphins aren't the only animals to exhibit this remarkable sleep pattern. Some species of seals and sea lions can sleep this way when in water, though they return to normal bihemispheric sleep when on land. Certain species of birds, particularly those that make long migratory flights, also show unihemispheric sleep. Frigate birds, for example, can fly for weeks at a time, crossing entire oceans, and they use this half-brain sleep to rest while soaring on air currents, always keeping one hemisphere aware enough to maintain flight and avoid collisions. But among marine mammals, dolphins have perfected this art. It's their default mode of sleep, their only way of resting. They've been doing it for millions of years, through countless generations, each one learning the rhythm of switching hemispheres, of balancing rest with awareness, of sleeping while swimming, of dreaming with one eye open. Interestingly, recent research has found that humans may experience a mild version of this phenomenon. Studies on what's called the first night effect, that restless sleep we often experience in unfamiliar places, show that one hemisphere of the human brain, usually the left, remains more alert than the right during the first night in a new location. It's not full uni-hemispheric sleep, the difference is subtle, but it suggests that the capacity for asymmetric brain activity during sleep may be more widespread than we thought. Perhaps it's an ancient survival mechanism, lurking in the depths of mammalian evolution, fully expressed in dolphins but present as an echo in us. As you lie in your bed tonight, both hemispheres of your brain will soon synchronize into sleep. You'll close both eyes, your awareness of the room around you will fade. You'll sink into that vulnerable but restorative state of complete unconsciousness. It's a luxury, in a way one that dolphins can never fully experience. But perhaps there's something beautiful in their alternative, something poetic about never completely disconnecting from the world, about always maintaining that thread of awareness, about sleeping while still present, resting while still swimming through the endless blue. The ocean rocks them gently. One hemisphere sleeps, the other watches, and in this rhythm, in this ancient pattern of rest and awareness, dolphins have found their peace. A different kind of sleep than ours, but sleep nonetheless. Rest, restoration, and the quiet turning of consciousness from one side of the brain to the other, like the slow roll of waves against the shore. The ocean is never truly silent. Beneath the surface, beyond the reach of air and wind, sound travels in ways that seem almost magical. It moves faster through water than through air, more than 4 times faster, carrying farther, penetrating deeper, creating an acoustic landscape that dolphins navigate with the same ease we navigate the visual world. And in this world of sound, dolphins have developed a language of extraordinary complexity. Listen to the ocean with the right equipment, and you'll hear it. The distinctive whistle of a dolphin, rising and falling in frequency, swooping through octaves like a melodic signature. That's exactly what it is. A signature. Each bottlenose dolphin develops its own unique whistle during the first year of life. A sound pattern that functions like a name. It's their vocal calling card, their way of saying "this is me." And remarkably, dolphins not only produce their own signature whistle consistently throughout their lives, they also learn and remember the signature whistles of other dolphins they know. The discovery of signature whistles was groundbreaking. Scientists had long observed that dolphins produced a variety of sounds, whistles, clicks, burst pulse sounds, and other vocalizations. But it wasn't until careful recording and analysis that the pattern became clear. When dolphins were temporarily separated from their group, they would produce their signature whistle repeatedly, as if calling out their name, trying to reconnect. When 2 dolphins who knew each other encountered one another after a separation, they would often exchange signature whistles, a kind of vocal greeting. "Hello, I'm here. Hello, I recognize you." But signature whistles are just the beginning. Recent research has uncovered another layer of dolphin communication, non-signature whistles. These are shared sounds, used by multiple dolphins in a population that appear to carry specific meanings. Researchers studying dolphins in Sarasota Bay, Florida, have identified 22 different types of non-signature whistles so far. 2 of them, creatively named NSWA and NSWB, are particularly common and appear across dozens of individual dolphins. Through careful playback experiments where researchers play recorded whistles to dolphins and observe their reactions, scientists are beginning to decode what these sounds might mean. NSWA, for instance, seems to function as an alarm call. When it's played to a dolphin, they often respond with avoidance behaviors, turning away or swimming away from the source of the sound. It's as if someone shouted danger, and the dolphin responded appropriately. NSWB, on the other hand, elicits more uncertain or inquisitive behavior. Dolphins might approach the sound, circle, or respond with vocalizations of their own, often repeating NSWB back. It could be a query, a questioning sound, something like "what's happening?" or "did you say something?" The fact that multiple dolphins use the same non-signature whistles, and that these whistles are learned rather than innate, suggests something profound. It hints at the possibility of a dolphin vocabulary, a set of shared sounds with agreed-upon meanings. It's not language in the full human sense. Dolphins don't appear to have complex grammar or the ability to create endless novel sentences from recombining words. But it may be a basic vocabulary, a small lexicon of important concepts that dolphins can use to communicate specific information to one another. The way dolphins develop their signature whistles reveals something beautiful about their social learning. Young calves, in their first months of life, produce a variety of experimental sounds. They listen to the whistles of their mother, their siblings, other members of their pod. Gradually, they settle on their own unique pattern, often incorporating elements from the whistles they hear around them, but arranging them in a novel way. It's like a child learning to speak, absorbing the sounds of their language, experimenting with different combinations, and eventually finding their own voice within that linguistic tradition. Mothers appear to play a special role in this process. Research has shown that female dolphins modify their signature whistles when in the presence of their calves, making them slightly different from when they're with other adult dolphins. They increase the maximum frequency, they broaden the frequency range, they make their whistles more distinctive and easier for a young calf to perceive and learn from. This is strikingly similar to what human parents do with infant-directed speech, that baby talk or motherese we use with infants, characterized by exaggerated intonation, slower tempo, and clearer pronunciation. The function appears similar too, to facilitate learning, to strengthen the bond between mother and offspring, to create a clear channel of communication during a critical developmental period. This signature whistle, once developed, becomes a permanent part of the dolphin's identity. It doesn't change significantly over their lifetime. Dolphins who've been separated for 20 years can still recognize each other's signature whistles when they hear them again. Think about that for a moment. 2 decades. That's longer than many friendships last in human lives. Yet dolphins carry these acoustic memories across their entire lifespan, ready to recognize a voice from the past, to reconnect with relationships forged long ago. Dolphins can also mimic the signature whistles of others. When they want to address a specific individual, they can produce that individual's whistle, essentially calling them by name. This referential communication, using learned signals to refer to specific individuals, was long thought to be unique to humans. But dolphins do it too. They call to each other across the blue expanse, using names, maintaining contact, strengthening bonds, even when separated by distance. Beyond whistles, dolphins produce clicks, thousands of them per second in rapid-fire sequences called click trains. These aren't primarily for communication, though they may serve that function secondarily. Their main purpose is echolocation, a topic we'll explore more deeply in the next section, but they're part of the rich acoustic tapestry of dolphin sound, adding texture and rhythm to their underwater world. There are also burst pulse sounds, rapid series of clicks that blend together into buzzing or chirping noises. These appear to express emotion or intention. Aggressive encounters often feature buzz sounds. Courtship may involve pulsed yelps. Distress or alarm can produce pulsed squeaks. The exact meanings are still being studied, but it's clear that these sounds carry information about the dolphin's emotional and motivational state. All of these sounds are produced not by vocal cords, which dolphins don't have, but by a complex system of air-filled nasal passages and specialized structures called phonic lips. Air is pushed through these structures, causing them to vibrate and produce sound. Dolphins have 2 sets of phonic lips and can operate them independently, producing clicks and whistles simultaneously if needed. The sounds are then focused and directed by the melon, that bulbous forehead structure filled with specialized fatty tissue, which acts as an acoustic lens, shaping and projecting the sound waves out into the water. When you understand all of this, when you grasp the sophistication of dolphin communication, it becomes clear that something remarkable is happening beneath the waves. A species that can't use facial expressions, can't gesture with hands, can't write or draw, has nevertheless developed a rich system of acoustic signals for maintaining relationships, coordinating activities, and navigating their social world. They've created a way to say, "This is who I am. I'm here, danger. Come here. I recognize you." They've developed the capacity for individual identity, for names, for calling across distance, for remembering voices across decades. And perhaps most wonderfully, they're still teaching us. But every new study, every careful recording and analysis, every playback experiment and observation, we learn a little more about what dolphins are saying to each other. We decode another whistle type, uncover another pattern, glimpse another piece of their acoustic world. The conversation between species isn't one-sided anymore. We're starting to listen, really listen, to what dolphins have been saying all along. As you drift towards sleep, imagine the ocean filled with voices, each dolphin carrying their unique signature, their personal song. Calves learning from mothers, friends calling across the blue, alarms spreading through a pod, questions asked and answered in frequencies too high for human ears. An entire society conducting its business through sound, through the language of clicks and whistles, through the shared vocabulary of an ancient marine culture. And somewhere in that acoustic tapestry, in that conversation that spans the seas, there's room for wonder, room for mystery, room for all the whistles we haven't yet decoded, all the meanings we're still learning to hear. In the depths where sunlight cannot reach, where particles and sediment cloud the water, where the blue fades to black, vision becomes almost useless. Yet dolphins navigate these spaces with ease, hunting, playing, and exploring as confidently as we walk through a lit room. Their secret is echolocation, a biological sonar so sophisticated that engineers have spent decades trying to replicate even a fraction of its capabilities. The process begins with a click, not the slow, deliberate click of a pen or a camera shutter, but a sound so brief it barely registers, 40 to 70 microseconds, less than a tenth of a millisecond, a sharp pulse of sound containing frequencies that span from a few kilohertz up to over 120 kilohertz, far beyond the range of human hearing. These aren't gentle sounds either. At close range, a dolphin's echolocation click can reach about 220 decibels, loud enough that it would be painful if we could hear it, though much of that energy is at frequencies our ears can't detect. Dolphins produce these clicks using their phonic lips, those specialized structures in their nasal passages. Air is shuttled back and forth through the system, allowing them to produce continuous streams of clicks without having to surface for fresh air. The clicks pass through the melon, that dome of fatty tissue on their forehead, which acts as an acoustic lens, focusing the sound into a directed beam. Think of it like a flashlight beam, but made of sound instead of light. The dolphin can control the shape and direction of this beam, adjusting the acoustic properties of the melon to focus the sound more narrowly or spread it wider depending on what they're investigating. The sound beam travels forward through the water until it encounters something, a fish, a rock, another dolphin, the seafloor. When the sound waves hit this object, some of the energy is absorbed, but much of it bounces back. The echo travels back toward the dolphin, carrying with it information about whatever created it. The dolphin receives this returning echo not through its ears, but primarily through its lower jaw, which is filled with the same kind of acoustic fat found in the melon. The sound travels up through this fat to the middle ear, and from there to the brain, where it's processed at remarkable speed. From this echo, from this brief pulse of returned sound, the dolphin can determine an extraordinary amount of information. Distance is easy, calculated from the time it takes for the echo to return. The speed of sound in water is known, about 1500 meters per second, so if the echo returns in 1/100th of a second, the object is about 7.5 meters away. But dolphins extract so much more than just distance. They can determine size. Larger objects reflect more sound, creating stronger echoes. They can determine shape. A sphere creates a different echo pattern than a cylinder or a cube. The structure of the returning echo, its frequency content and time signature, carries information about the three-dimensional form of the object. They can even determine internal structure. Research has shown that dolphins can distinguish between hollow and solid objects of the same size, and they can detect the swim bladder inside a fish, that gas-filled organ that helps fish control their buoyancy. The swim bladder acts like a mirror for sound, creating a strong reflection, which is why dolphins are so good at finding fish even in murky water. The precision of this system is staggering. Bottlenose dolphins can detect a steel sphere 7.6 centimeters in diameter from over 100 meters away. They can distinguish between aluminum cylinders that differ in wall thickness by less than 1/4 of a millimeter. They can detect objects as small as a ping-pong ball at ranges of several meters. When presented with objects that differ in size by only about 10%, dolphins can tell them apart reliably. This is resolution that rivals or exceeds what we can achieve with our best human-made sonar systems. But echolocation isn't just about detection. It's about creating a mental representation of the environment. When researchers conducted cross-modal matching experiments, they discovered something remarkable. They would let a dolphin inspect an object using only echolocation, never seeing it. Then they'd present several objects visually and ask the dolphin to indicate which one matched what they'd just echolocated. Dolphins could do this accurately. They could also do the reverse, inspecting an object visually and then identifying it using echolocation alone. This means the dolphin brain creates some kind of abstract representation of objects that's independent of the sensory modality used to perceive them. Whether they see with sound or eyes, the resulting mental image is compatible, comparable, usable in the same way. Dolphins adjust their echolocation for different situations. When scanning at long range, they use what researchers call click packets, bursts of clicks followed by a pause, to listen for returning echoes. As they get closer to a target, the rate of clicking increases. When they're very close, within a few body lengths, they may slow down again and use different click patterns to examine fine details. During the final approach to prey, they often switch to a buzz pattern, hundreds of clicks per second, providing them with a continuous real-time acoustic image as they close in for the catch. The hunting strategies that echolocation enables are impressive. In shallow coastal waters, dolphins have been observed using a technique called fish corralling or fish herding. They swim in coordinated patterns, using their bodies and their echolocation to drive schools of fish into tighter and tighter groups, often pushing them toward shore or into shallow water where they're easy to catch. In Florida, some dolphins perform mud-ring feeding, swimming rapidly in circles to stir up the bottom sediment, creating a ring of turbid water that confuses and traps fish. The fish jump over the mud ring to escape, and the waiting dolphins catch them in mid-air. These strategies require not just echolocation, but coordination among multiple dolphins, each one using their sonar to keep track of the fish, their companions, and the environment. Echolocation also plays a role in social interactions. While signature whistles are the primary means of identification, echolocation clicks can provide additional information about who's nearby. The characteristics of a dolphin's clicks may be as individual as their whistle, and dolphins may be able to eavesdrop on each other's echolocation, listening to the echoes that bounce off objects and extracting information from them. It's even been suggested, though not yet proven, that dolphins might be able to create acoustic images for each other, mimicking the structure of an echo to essentially show another dolphin what they saw. It would be like transmitting a picture via sound, a form of communication that we can barely imagine but that might be possible given their incredible acoustic control. There are limitations, of course. High-frequency sounds don't travel as far in water as low frequencies, so echolocation is primarily useful at shorter ranges, typically up to about 100 meters for most objects. Beyond that, dolphins rely more on vision and passive hearing. The system also requires energy and attention. A dolphin actively echolocating is engaged in an effortful process, generating sounds, processing echoes, building and updating that mental acoustic map. It's not automatic or unconscious the way vision often feels to us. It requires focus. But within its operational range, dolphin echolocation represents one of the most sophisticated sensory systems in the natural world. It allows them to navigate in total darkness, to hunt prey they cannot see, to inspect objects with extraordinary detail, to operate in environments where we would be utterly blind. It's a different way of perceiving reality, a different kind of sensory experience, one built entirely on sound, on the echoes of self-generated clicks bouncing back from the world. Engineers and scientists have long looked to dolphin echolocation for inspiration. Military sonar systems, medical ultrasound devices, underwater robotics, all have borrowed principles from how dolphins see with sound. Yet even our best technology still falls short of what a dolphin can do. The miniaturization, the processing speed, the adaptability, the discrimination ability, these remain at the cutting edge of biological engineering, refined over millions of years of evolution. As you settle into sleep, imagine perceiving the world through sound, every click creating a picture, every echo adding detail. Imagine swimming through darkness, yet never being lost, never uncertain, because the returning sounds paint the environment in your mind as clearly as light paints it for our eyes. Imagine a world where silence means blindness and sound means sight, where every object has an acoustic signature, where the seafloor and the surface, the rocks and the fish, the friends and the foes, all reveal themselves through the patient work of listening. Dolphins live in this world. They've mastered it, and in their mastery, they offer us a window into a completely different way of experiencing reality, a reminder that intelligence and perception can take forms we're only beginning to understand. The ocean is vast, yet dolphins rarely swim alone. They gather in groups, form bonds, create societies of remarkable complexity. These aren't random aggregations, not simple herds moving together out of instinct. Dolphin societies are dynamic, intentional, built on relationships that can span entire lifetimes. Scientists call them fission fusion societies, a term that captures their fluid nature. Imagine your own daily life. In the morning, you're with family. Then you go to work, and you're with colleagues. At lunch, perhaps you meet a friend. In the evening, you join a different group for an activity. Throughout the day, you fuse into different groups and then fission away from them, but all within a larger social network of people you know and interact with regularly. Dolphins live the same way. They move between different groups throughout the day, sometimes joining with just a few close companions, other times merging into larger aggregations of dozens or even hundreds of individuals. But always, beneath this constant shifting, there are relationships, preferences, histories. The fundamental building block of dolphin society is the mother-calf bond. When a calf is born, after about 12 months of gestation, it stays close to its mother almost constantly. The first few days, the mother helps position the calf at the surface to breathe. She nurses it frequently, sometimes every few minutes in those early days. She protects it from anything that might pose a threat, and she begins the long process of teaching. This teaching is subtle but comprehensive. The calf learns by watching its mother hunt, by observing how she interacts with other dolphins, by gradually understanding the social rules and strategies of their pod. In some dolphin populations, mothers teach their young to use tools. In Shark Bay, Australia, dolphins have been observed breaking off marine sponges and wearing them over their rostrums while foraging on the seafloor. The sponge protects their sensitive snout from abrasion as they root through the sediment searching for buried fish. This isn't instinctive behavior. It's learned, passed from mother to daughter, transmitted across generations as a cultural tradition. The mother-calf bond remains strong for years. Even after a calf is weaned, around 18 months to 2 years of age, it continues to associate closely with its mother for several more years. The relationship only begins to loosen when the mother has another calf, usually around 3.5 years after the previous birth. At that point, the older offspring becomes more independent, though family connections often persist throughout life. For female dolphins, social relationships are heavily influenced by reproductive status. Pregnant females tend to socialize with other pregnant females. Females with young calves form nursery groups, banding together for mutual protection and assistance. These nursery groups can be thought of as a kind of cooperative childcare, where mothers help watch each other's young, where the collective vigilance of several adults provides better protection than a single mother could manage alone. The calves in these groups often play together, learning social skills while their mothers forage nearby. Male dolphins follow a different social trajectory. As they mature, they often form close partnerships with other males, typically 2 or 3 individuals who spend most of their time together. These partnerships, sometimes called alliances, can last for decades. Researchers tracking dolphins in Shark Bay have documented male partnerships that persisted for 15-20 years or more. The males coordinate their movements, hunt together, rest together, and support each other in interactions with other groups. These male alliances serve multiple functions. They improve hunting success through coordination. They provide protection against predators and aggressive interactions with other males. And critically, they help in mating opportunities. 2 or 3 allied males can cooperate to escort or herd a female, keeping her away from other males and ensuring mating access. While this herding behavior can sometimes appear coercive, it's part of the complex mating strategies that have evolved in dolphins. The males in an alliance support each other, taking turns, ensuring that all members of the alliance get opportunities to reproduce. But it gets more complex. These male alliances sometimes form super-alliances with other groups of males. When 2 or 3 pairs or trios cooperate, They create larger coalitions that can defend territories, compete with other super-alliances, and dominate social interactions across a wider area. The politics of these multi-level alliances rival the complexity seen in chimpanzees and humans. Individual males must remember who their direct partners are, who their super-alliance partners are, who they can trust, who they're competing with, and how these relationships might shift over time. Communication is essential to maintaining these relationships. Dolphins use their signature whistles to keep in contact, especially when groups are spread out over larger areas. A mother and calf separated for a while will call to each other. Members of a male alliance will whistle back and forth, coordinating movements. When different groups meet, they often engage in whistle exchanges, almost like verbal greetings, establishing identity and intention before any physical interaction occurs. But dolphins also communicate through touch. Pectoral fin contact, rubbing their flippers against each other, is a common bonding behavior. They swim in synchrony, matching their movements precisely, which appears to strengthen social connections. They engage in play together, chasing, leaping, tossing objects back and forth. These behaviors aren't just for fun, though they certainly appear joyful. They serve the serious purpose of building and maintaining the relationships that hold dolphin society together. The recognition of individual relationships means that dolphins have what researchers call a social memory. They remember who they've interacted with, how those interactions went, who they can rely on, who they should be cautious around. When a dolphin encounters another after a long separation, they can immediately recall their relationship history and behave accordingly. This requires substantial cognitive resources, essentially maintaining a mental map of dozens or hundreds of social relationships, updating it constantly as interactions occur. Dolphins also show helping behaviors that suggest empathy and altruism. There are documented cases of dolphins supporting injured companions, lifting them to the surface to breathe, even though this requires significant effort. They've been observed defending weaker individuals from aggressive interactions. In some cases, dolphins have helped members of other species. Stories of dolphins assisting humans aren't just myth or wishful thinking. There are verified accounts of dolphins seemingly protecting swimmers from sharks or guiding lost swimmers back to shore. Whether these behaviors stem from the same empathic impulses that drive helping within their own species, or whether they represent something else, curiosity perhaps, or misidentified social cues, remains debated. But they occur, documented by enough credible observers to be taken seriously. The size of dolphin groups varies depending on the environment and available resources. In coastal areas, pods typically range from 2 to 15 individuals. In deeper, more open waters, groups can be much larger. When food is abundant, multiple pods may merge temporarily into superpods numbering in the hundreds or even thousands. These superpods don't last long, usually just hours or at most a few days, but they represent massive social gatherings where dolphins from different areas come together, interact, exchange information, and perhaps forge new relationships. Throughout all of this, throughout the constant movement and interaction, dolphins maintain individual personalities. Some are bold and curious, approaching novel objects or situations with enthusiasm. Others are more cautious and reserved, hanging back and observing before deciding how to respond. Some are gregarious, constantly interacting with others, while some are more solitary, spending more time alone or with just one or two close companions. These personality differences are consistent over time and influence each dolphin's role in their social network. Bolder individuals often serve as scouts or initiators, the first to investigate something new or to lead the group in a new direction. The cognitive demands of this social life are immense. A dolphin must recognize dozens or hundreds of individuals, remember their relationships with each one, track who's allied with whom, anticipate how others might behave based on past interactions, and adjust their own behavior strategically to navigate this complex web. It's these demands, many scientists believe, that drove the evolution of their large, complex brains. Technical intelligence, the ability to manipulate physical objects and understand how the world works, provides some evolutionary advantage. But in the open ocean, where there are relatively few objects to manipulate and few problems that require tool use, social intelligence became paramount. The ability to cooperate, to communicate, to remember, to empathize, to predict what others will do, these became the skills that mattered most. And so dolphin brains grew and specialized to handle these challenges, creating the sophisticated social world we observe today. As you drift towards sleep, imagine being part of such a society. Imagine knowing dozens of voices, each one instantly recognizable. Imagine relationships that span decades, friendships that outlast most human marriages. Imagine moving through your day in constant communication with those around you, coordinating, cooperating, playing together. Imagine a life where you're rarely alone, where every day brings interactions with familiar faces, where your social network is your security, your livelihood, your joy. That's the world dolphins inhabit. A world rich with relationships, complex with social nuance, endlessly fascinating in its parallels to our own social lives, yet entirely submerged, entirely marine, entirely theirs. Watch dolphins for any length of time, and you'll see it. The leaping, the spinning, the chasing, the apparent abandon with which they move through the water. It's hard not to interpret these behaviors as expressions of joy. And while we must be careful about anthropomorphizing, about projecting our own emotional experiences onto other species, the scientific evidence increasingly supports what our intuition suggests. Dolphins experience emotions, rich and varied, including something very much like what we would call joy. Play is universal among dolphins, but it's not confined to the young. While juvenile dolphins certainly play extensively, adults also engage in playful behaviors throughout their lives. This is unusual. In most species, play is primarily a juvenile activity, a way to practice skills needed for adult life. It decreases dramatically or disappears entirely at maturity. But dolphins keep playing. 50-year-old dolphins have been observed engaging in the same playful activities as 5-year-olds. Some play is social. Dolphins chase each other in spiraling patterns, one pursuing, the other evading, neither with any apparent goal beyond the chase itself. They engage in gentle roughhousing, pushing, bumping, mouthing, without biting. They swim in perfect synchrony, matching each other's movements so precisely it seems choreographed. This synchronized swimming appears to strengthen bonds between individuals, creating a shared experience that reinforces their connection. Other play is object-oriented. Dolphins toss seaweed back and forth, catching it on their rostrum or flippers and flinging it to a companion. They've been observed carrying objects, sometimes for considerable distances, with no obvious purpose except to have something to carry. In some locations they play with fish, catching a fish but then releasing it, catching it again, sometimes passing it back and forth between individuals in an extended game that eventually ends with the fish being eaten, but only after many minutes of play. Then there are the bubble rings. This behavior is so enchanting, it's hard to describe without sounding whimsical. A dolphin will blow air from its blowhole while simultaneously moving in a circular motion, creating a perfect vortex of water. The air forms a ring, a torus shape that remains stable and travels through the water like a smoke ring travels through air. The dolphin then interacts with this ring, pushing it, spinning it, combining multiple rings, sometimes even swimming through them. Its creativity expressed in 3 dimensions, using nothing but air and water and precise movements. And it appears to serve no function except entertainment, exploration, play. Dolphins also engage in what can only be described as surfing. They ride ocean waves, positioning themselves in the wave face and gliding along with minimal effort, sometimes for minutes at a time. They bow ride, swimming in the pressure wave created at the front of boats or even large whales, using the hydrodynamic push to travel faster while expending less energy. While this has a practical aspect, allowing efficient travel, dolphins often bow ride when they don't appear to be going anywhere in particular, suggesting they do it because it feels good, because it's fun. The emotional depth that makes play possible also manifests in other ways. Dolphins have been observed grieving. When a calf dies, mothers sometimes carry the dead body with them for days, bringing it to the surface to breathe, refusing to let go even as decomposition makes it clear that the calf won't recover. Other pod members sometimes interact with the dead calf as well, touching it gently, as if in sympathy or shared mourning. These behaviors have been documented across multiple species of cetaceans and appear to represent a genuine emotional response to loss, a recognition that someone who was present is now gone. They also show what appears to be empathy and compassion. Beyond the helping behaviors mentioned earlier, dolphins have been observed comforting distressed companions, staying close, making gentle physical contact, producing soft vocalizations. When a pod member is sick or injured, others often adjust their pace and movements to accommodate them, slowing down, providing support, not abandoning them even when it would be easier to swim ahead. The limbic system, that part of the mammalian brain responsible for processing emotions, is highly developed in dolphins. Some neuroscientists suggest it may be even more complex than the human limbic system, implying that dolphins may experience emotions with an intensity or subtlety that equals or exceeds our own. Their spindle neurons, those specialized cells associated with social emotions like empathy, are present in greater numbers relative to brain size than in many other species. Frustration and anger also exist in their emotional repertoire. Dolphins can become aggressive, especially during mating competition or territorial disputes. They've been observed displaying aggression toward other species, including sharks, sometimes attacking them without apparent provocation. Whether this represents predation, competition, defense, or something else isn't always clear. But the behaviors indicate that dolphins experience the full range of emotions, not just positive ones. Individual dolphins have distinct personalities that remain consistent over time. Some are perpetually curious, always the first to investigate new objects or situations. Others are more reserved, hanging back, waiting to see what happens before committing to interaction. Some are playful almost constantly, while others are more serious, more focused on practical matters like hunting. These personality differences are observable, measurable, and they influence how dolphins navigate their social world and physical environment. Research into dolphin cognition has found that they can recognize themselves in mirrors, a capacity that indicates self-awareness. When presented with a mirror, after an initial period of treating it as another dolphin, they begin using it to inspect parts of their own body they can't normally see. They'll turn and twist, examining marks painted on them, using the mirror as a tool to see themselves. This self-awareness likely underlies their capacity for complex emotions. To feel embarrassed, proud, or self-conscious requires an awareness of self as separate from others, an internal model of me that can be compared against them. The joy dolphins appear to express, the curiosity they show toward their environment, the playfulness that continues throughout their lives. All of this suggests a quality of experience that goes beyond mere survival. They don't just exist in the ocean, they experience it. They find things interesting. They get bored and seek novelty. They create their own entertainment. They seem to value experiences not just for their utility, but for their intrinsic qualities, for how they feel. This emotional richness, this capacity for joy and play, makes dolphins relatable in a way that many other animals are not. When we watch them leap and spin, when we see them racing alongside boats, apparently delighting in the speed and motion, we recognize something of ourselves in them, a capacity for happiness, for finding pleasure in movement and sensation, for being curious about the world just because curiosity feels good. As you rest tonight, as your own emotions settle and quiet, think about the dolphins out there in the ocean, some sleeping with half their brain while the other half watches, some still active, hunting or socializing or playing. Consider that they're not just biological machines, not just collections of instincts and reflexes. They're beings with inner lives, with experiences colored by emotion, with preferences and personalities, with the capacity to feel joy in a sunset's light filtering through the waves, or satisfaction in a hunt well executed, or the simple pleasure of swimming fast through clean water. They're alive in the fullest sense, aware, feeling, present, and in their presence, in their apparent joy, there's something that speaks to us across the evolutionary distance that separates our species, a reminder that consciousness and emotion aren't human monopolies, that the spark of subjective experience illuminates many corners of the natural world, especially in the minds of these ocean wanderers who carry such large brains and such evident love of life. In the vastness of the ocean, where currents flow and waters mix, where individuals could easily drift apart and lose contact, dolphins maintain relationships that can span their entire lives. These aren't mere acquaintances, not chance encounters that happen to repeat. These are bonds, deep and enduring, comparable in their strength and significance to the most important human relationships. The mother-daughter connection often extends across decades. A female calf may stay associated with her mother into adulthood, sometimes maintaining contact even after both have calves of their own. They recognize each other's signature whistles instantly. They preferentially associate, swimming together, hunting together, coordinating their movements. When they encounter each other after a separation, their reunion is marked by increased vocalizations, by physical contact, by behaviors that suggest genuine pleasure at being together again. Grandmothers, too, play a role in dolphin society. In populations with matrilineal stability, where female dolphins tend to remain in the area where they were born, older females form the core of the social network. They've accumulated decades of knowledge about the local area, about where food can be found seasonally, about safe routes and dangerous zones. Younger females can learn from them, not just through direct teaching but through observation and following. The presence of these older experienced females may increase the survival rates of younger dolphins and their offspring. The male alliances mentioned earlier are another form of lifelong bond. When two male dolphins form a partnership in adolescence, that relationship often persists until death. They spend nearly all their time together. They coordinate their actions so precisely that they move as a unit. They know each other's signature whistles, behavioral tendencies, strengths and weaknesses. They depend on each other for success in mating, for protection from other males, for companionship across the decades. These relationships require maintenance. Bonds can weaken, if not reinforced through regular interaction. Dolphins that spend time apart may need to rebuild their relationship through increased physical contact, through longer periods of synchronized swimming, through more frequent vocal exchanges. It's similar to human friendships, where regular contact keeps the relationship strong, but distance and separation can cause it to fade, requiring deliberate effort to restore. There's evidence that dolphins experience something like friendship preference within a pod. Not all relationships are equal. Some pairs spend significantly more time together than would be expected by chance. Some individuals consistently choose to swim near each other, to engage in mutual grooming through pectoral fin rubbing, to rest in proximity. These preferred associates are often, but not always, related. Sometimes they're individuals of similar age who matured together. Other times they're individuals whose personalities seem to complement each other. Bold paired with cautious, experienced with young. The transmission of knowledge across generations creates something like culture. In different regions, dolphin populations have developed unique foraging strategies that are learned rather than innate. The sponge tool use in Shark Bay is one example. Another is strand feeding, seen in some southeastern US populations, where dolphins chase fish onto mudbanks and briefly beach themselves to catch the fish, then wriggle back into the water. This is learned behavior, taught by mothers to their young, risky if done incorrectly but highly effective when mastered. Different populations also have different signature whistle patterns, different dialects essentially. Dolphins from one region produce whistles with slightly different frequency characteristics than dolphins from another region, even of the same species. A dolphin moving between populations would be identifiable as an outsider by their acoustic accent, much as a human moving between regions would be recognizable by their speech patterns. These cultural traditions mean that dolphin populations aren't just genetically distinct, they're culturally distinct too. The loss of a population isn't just the loss of a gene pool, it's the loss of accumulated behavioral knowledge, of traditions that may have been passed down for hundreds of generations, of skills and strategies adapted to local conditions over countless years. The bonds dolphins form with each other also extend, occasionally, to other species. There are documented cases of dolphins forming associations with whales, swimming alongside them for extended periods. Some dolphins have been observed interacting repeatedly with the same individual humpback whales, recognizing them year after year when they return to feeding grounds. The purpose of these interspecies relationships isn't always clear. They may provide protection, companionship, or access to food resources through the whale's foraging activities stirring up prey. Or they may simply be social, a manifestation of dolphins' general gregariousness extending even beyond species boundaries. When dolphins are separated from their social group, whether through human intervention in captivity or through natural events like storms or stranding, they show signs of distress. They vocalize more frequently, producing their signature whistle repeatedly as if calling for companions. They become less active, less engaged with their environment. These responses suggest that social connection isn't just beneficial for dolphins, it's fundamental to their well-being. They're not just animals that happen to group together for practical reasons. They're inherently social, deeply connected to their companions, dependent on those relationships for psychological health as much as for physical survival. The capacity to maintain these long-term relationships requires exceptional memory. A dolphin must remember not just faces, or in this case acoustic signatures, but entire histories of interaction, who helped them when they needed it, who competed with them for resources, who can be trusted in a conflict, who's allied with whom. This social memory must persist across years, even decades, ready to be recalled when needed to guide behavior in a new interaction. As you settle deeper into rest, imagine carrying such memories. Imagine recognizing a friend you haven't seen in 20 years by their voice alone. Imagine maintaining relationships across distances and time, tied together by memory and recognition, and the choice to remain connected. Imagine a life where your social bonds are so strong, so central to your existence, that solitude would feel like a kind of death, where companionship isn't just pleasant but necessary. Dolphins live this reality. Their bonds tie them to each other across the ocean's vast spaces. Their relationships define much of who they are, how they spend their time, what strategies they pursue in life. They're social beings in the deepest sense, built for connection, shaped by millions of years of evolution, to value and maintain relationships that enrich their lives and ensure their survival. In the ocean's blue expanse, in its seemingly impersonal vastness, dolphins create points of connection, threads of relationship, networks of companionship. And in those networks, in those bonds that persist across lifetimes, there's something profoundly beautiful, something that reminds us that intelligence, wherever it emerges, often comes with a capacity for connection, for recognizing others as individuals worth knowing, worth remembering, worth maintaining relationships with across all the years of life. To watch a dolphin swim is to witness one of nature's masterworks of engineering and elegance. Every movement is fluid, every turn precise, every acceleration seemingly effortless. They are in the fullest sense at home in their element, shaped by millions of years of evolution to move through water with a grace that few other creatures can match. The dolphin body is hydrodynamic perfection. The fusiform shape, wider in the middle and tapering at both ends, allows water to flow smoothly around them with minimal resistance. The skin is smooth and somewhat elastic, conforming to the pressure of moving water in ways that reduce turbulence. Even the eyes sit flush with the body, not protruding, maintaining the streamlined profile. Every feature, from the position of the dorsal fin to the shape of the flukes, has been refined by natural selection for efficient movement through a liquid medium. But shape alone doesn't explain their speed and agility. Dolphins can swim at speeds exceeding 35 kilometers per hour in short bursts, fast enough to chase down most fish. They accomplish this through powerful movements of their tail flukes, not side to side like fish, but up and down, using the strong muscles of their lower back and tail stalk to drive themselves forward. The flukes are perfectly shaped lifting surfaces, generating thrust on both the upstroke and downstroke, more efficient than simple paddling. Yet they can also swim very slowly when needed, barely moving, hanging almost motionless in the water. This range of speeds, from nearly stationary to sprint, allows them to match their pace to their activity. Resting, they drift. Traveling, they cruise at moderate speeds that they can maintain for hours. Hunting or evading, they accelerate to those burst speeds that make them some of the fastest mammals in the ocean. Their agility matches their speed. Dolphins can turn sharply, spinning their body on its axis, reversing direction almost instantly. They can dive deep and rise quickly, controlling their buoyancy through lung volume and the compression of gas spaces at depth. They can leap from the water, sometimes clearing the surface by 3 meters or more, spinning or flipping in midair before crashing back with a tremendous splash. These aerial displays serve multiple purposes: communication, parasite removal, stunning fish, or perhaps sometimes just play. The leaps are spectacular to watch. A dolphin accelerates toward the surface, building speed, then angles upward and breaches with enough momentum to carry it high into the air. While airborne, some dolphins spin, rotating around their longitudinal axis like a corkscrew. Others flip end over end, showing their pale belly to the sky before splashing back down. These acrobatic feats require precise control over body position and momentum, a kinesthetic awareness of where they are in space and how their movements will affect their trajectory. Synchronized swimming is another remarkable behavior. Multiple dolphins will swim in perfect coordination, matching their speeds, turning together, leaping together, as if choreographed. This synchronization requires each dolphin to constantly monitor the position and movements of their companions, adjusting their own swimming to maintain the pattern. It's a display of neural coordination, of the ability to anticipate and match another's movements in real time. Why they do it isn't entirely clear. It may strengthen social bonds, demonstrate fitness, or simply feel good, like dancing in formation. Bow riding is a special case of synchronized swimming, where dolphins position themselves in the pressure wave created at the front of a boat or large whale. The wave pushes them forward, allowing them to travel at high speeds while expending minimal energy. Dolphins clearly enjoy this activity, often seeking out boats specifically to bow ride, racing to reach the bow position and jostling with companions for the best spot. They'll ride for minutes or even longer, sometimes leaving the pressure wave to leap and then rejoining it, apparently just for the thrill. Resting behavior shows a different kind of grace. When dolphins rest, often in the unihemispheric sleep state, they may swim very slowly in a line or circle, their bodies relaxed, movements minimal. Sometimes they hang motionless at the surface, logging, their dorsal fin and back exposed to the air. These quiet moments contrast sharply with their active periods, demonstrating their ability to modulate their energy expenditure, to be still when stillness serves them. Beneath the surface, their swimming takes on a different character, without the air-water interface to break through. They move through the three-dimensional space with even more freedom. They can spiral, roll, dive at angles that would be impossible on land. They use the entire water column, from surface to seafloor, choosing their depth based on where prey is, where they want to rest, or perhaps just where they feel like being. This vertical dimension adds complexity to their spatial awareness. They must track not just where they are horizontally, but also how deep they are, how much air they have left before needing to surface, how long it will take to reach the surface from their current depth. The pectoral flippers, though not the primary source of thrust, provide steering and stability. A dolphin can use them like rudders, changing direction with subtle shifts in flipper angle. They also use them for tactile communication, touching other dolphins, feeling their way past obstacles, examining objects they're curious about. The flippers are surprisingly flexible, with bones analogous to our arm and hand bones, though modified into the flipper shape. This skeletal structure is a reminder of their evolutionary heritage, their ancestors who walked on land before returning to the sea. Their tail stalk is incredibly muscular, packed with the powerful muscles needed to drive those flukes through the water hundreds or thousands of times a day. This muscular region gives dolphins their distinctive shape, bulky in the rear third of the body, narrowing toward the flukes. The continuous work of these muscles generates heat, which is part of how dolphins maintain their body temperature in water that's often cooler than their bodies. All of this physicality, all of this motion, is guided by a sophisticated nervous system and brain. The motor cortex, the part of the brain that controls voluntary movement, must constantly process sensory information and translate it into muscle commands. Every turn, every leap, every precise positioning in a bow wave requires calculation and coordination, yet it appears effortless, because dolphins have been doing it their entire lives. Their brains optimized for these movements, their practice measured not in hours but in years. To watch them is to see efficiency and grace combined. They don't waste energy on unnecessary movements. They don't struggle against the water. They work with it, using its properties, flowing through it like it's their natural element, which of course it is. They were born in water. They've never breathed air without returning immediately to water. Their entire existence from conception to death unfolds in this liquid world, and their bodies show it in every smooth curve, every effortless glide, every powerful thrust that sends them surging forward. As your own body relaxes into the support of your bed, as your muscles release tension and sink into rest, imagine moving through water with such ease. Imagine your element welcoming you, supporting you, allowing you to move in 3 dimensions with grace and power. Imagine never fighting gravity, never straining to maintain position, just existing in perfect equilibrium with your environment. That's what dolphins experience every moment of their lives. A physical freedom we can only approximate, a harmony with their medium that we, as terrestrial beings, can admire but never fully share. We've journeyed far tonight, through the world of dolphins, from the folds of their remarkable brains to the patterns of their sleep, from their languages of sound to their social bonds, from their playful leaps to their graceful movements through endless blue. And what emerges from all of this, what ties it together, is a portrait of beings who are in their own way as complex and aware as we are. Different, certainly. Adapted to a completely different environment, but alive in the fullest sense, conscious, feeling, thinking, remembering, relating. Dolphins have been swimming in Earth's oceans for millions of years. They've watched civilizations rise and fall from their submerged perspective. They were here long before us, and if we're careful, they'll be here long after. They carry within their bodies and behaviors the accumulated wisdom of countless generations, adaptations refined over geological timescales, social traditions passed down through chains of teaching and learning that stretch back beyond our capacity to trace. In their intelligence, we see echoes of our own cognitive capacities, convergent evolution arriving at similar solutions to different problems. In their social bonds, we recognize the importance of connection, of maintaining relationships across time and distance. In their play and apparent joy, we see that life can be more than simple survival, that there's room for experience, for curiosity, for finding pleasure in sensation and motion. In their communication, we glimpse the possibility that meaning can be conveyed across the vast divide that separates species, that understanding might flow not just between humans but between humans and other forms of consciousness. They remind us that we share this planet with other minds, other perspectives, other ways of being intelligent and aware. The ocean is not empty, it's not a blue desert. It's filled with life, including lives that have depth and richness that deserve our respect, our protection, our wonder. As you drift towards sleep now, as your breathing slows and your thoughts begin to scatter and dissolve, carry with you an image of dolphins swimming through moonlit waters. Somewhere, right now, they're out there. Some sleeping with half their brain drifting at the surface, breathing slowly, peacefully. Others hunting in the depths, their clicks echoing through the darkness, painting acoustic pictures of a world we can barely imagine. Still others playing, leaping under stars, their bodies silver in the darkness, their splashes luminescent with disturbed bioluminescence. They're calling to each other, their signature whistles carrying across the waves. They're touching fins with companions, strengthening bonds. They're watching their calves learn to hunt, passing on knowledge that they received from their own mothers. They're part of the great, ancient, ongoing story of life in the ocean, a story that continues every moment, every day, in depths and distances we rarely consider. You are connected to them. The oxygen you breathe was partly produced by ocean organisms. The water cycle that brings rain to your home began with evaporation from their ocean. The atoms in your body have cycled through ocean ecosystems countless times across Earth's history. And perhaps most importantly, the capacity for consciousness, for awareness, for subjective experience didn't arise independently in humans. It's part of a much older inheritance, a flame passed from ancestor to descendant, burning now in human minds and dolphin minds and many others, each experiencing reality from their unique perspective. Tonight, as you rest, the dolphins rest too, in their way. The ocean rocks them gently. The current carries them where it will. Half their brain sleeps, half watches. They dream perhaps, though we can't know for certain what a dolphin dreams of. The same neurons that fire when they swim or hunt fire again in sleep, rehearsing, processing, consolidating memory. They wake when needed, breathe and sleep again. It's a peaceful image, isn't it? The ocean at night, vast and dark, filled with sleeping dolphins. Some alone, some in small groups, all drifting in that strange state of half-sleep, never fully unconscious, never fully separated from the world around them, but resting nonetheless. The waves roll across them, the moon moves across the sky, the planet turns, and the dolphins breathe, and sleep, and dream their dolphin dreams. You've heard tonight about their intelligence, their sleep, their communication, their relationships, their emotions, their grace. You've learned that they remember friends for 20 years, that they teach their young, that they play throughout their lives, that they experience joy and grief and curiosity. You've discovered that they see with sound, sleep with half a brain, name themselves with whistles, and maintain societies as complex as those of many primates. All of this is true. All of this has been revealed by patient scientific observation and careful study. But beyond all the facts, beyond all the fascinating details, there's something simpler. There are dolphins in the ocean. They live their lives. They matter. not because of what they can teach us or how they mirror us, but because they are themselves, valuable, irreplaceable, worthy of existence for no reason beyond existence itself. The ocean is richer for having them. The world is more interesting, more complex, more wonderful because dolphins swim through it. Rest now. Let the image of dolphins carry you into sleep. Their world is vast and blue and mysterious. Their minds are bright with awareness. Their voices echo through the depths, and somewhere, beneath the waves, they swim on through the night, graceful and ancient and alive, swimming through the same ocean that's been there since before memory. That will be there long after, timeless and patient and deep. The ocean breathes, the dolphins breathe, you breathe, all of it connected, all of it one system, one blue planet, one shared home where consciousness has bloomed in many forms, each one precious, each one part of the great mystery of being alive. Good night, sleep well, and may you dream of swimming through endless blue, of calling through the darkness and being answered, of belonging to a pod that knows your name and remembers your voice, of dancing through water without weight, without effort, without end. The dolphins swim on. The ocean holds them, and somewhere in that vast blue space, there is peace and rest and the gentle rhythm of waves, of breathing, of life continuing its ancient pattern, moment by moment, breath by breath, through the long, quiet night.